Okay. So nucleophile may nucleophile are rich in electrons, right? So if alcohol has to act as nucleophile, it's the lone pair of electrons on oxygen which are going to be the driving force. So this lone pair is going to attack carbon, and between R and hydrogen, which one can oxygen let go of more easily? Which one will
H.
H, right? So what is bonded to carbon over here? Like, will I end up with O? Like, okay, let me write this as R dash.
1 second, the OH group is attacking. You said where? Like it's the C will lose the H, right?
C will not lose the H.
Then
It's the oxygen that will lose the H, because oxygen is the one sharing its electrons, right? So it's suddenly become electron deficient. Like, so many atoms are sharing oxygen, like electrons with oxygen, it's not, like, octet is not satisfied. So because of that, oxygen is the one that has to break one of the bonds in order to have a proper octet.
I
So
don't understand why would oxygen have to break the bond with H?
because oxygen, like, how many bonds can oxygen have maximum? What is the valency of oxygen?
Uh,
Two.
two, yeah. Sorry.
So if oxygen already has a bond with hydrogen, has a bond with one carbon, and it's forming
Yeah.
a bond with this particular carbon.
Yeah.
It has to lose one of them. The easiest one to go would be hydrogen. It's the tiny atom. So
But
this,
why? Uh, like okay, yeah, I know the valence of oxygen is 2, but then why does it still have 2 lone pairs? Can't those also bond?
because oxygen has 6 electrons, like, it's, should I say, it's born with it. It's born that way. Okay. So yeah, this is the intermediate that we end up with. So this particular species, where you have carbon with hydroxy, like OH group, and a carboxy, like methoxy, alkoxy group. So this is called a hemiacetal. Okay. So this, again, if you remember your manufacture of ethers, like preparation of ethers, there's more alcohol in the solution. This will react with another mole of ROH in the presence of H plus, because HCl gas is there. And both of them are converted to alkoxy groups. So this particular species, this is called an acetal. Okay. For example, the like an application of where you will find this sort of a reaction being used, or like where you find this sort of a reaction would be the reaction with ethylene glycol. Actually, before that, let's discuss the ketone wala reaction also. So this, I want you guys to work on your own, because the mechanism will be the same. The only difference is, instead of aldehydes, we're going to deal with ketones. So we start off with R, C, double bond O, R, plus R dash OH. Make it simpler. Same reaction. So we have R dash OH in the presence of HCl gas. what is the intermediate that we get from this?
Will the double bond of the O like will be retained or no? Na,
That
it
becomes
will
a
break, right?
yeah, nucleophilic addition है ना, हमेशा nucleophilic addition में double bond addition reaction by definition, because things are
Yeah.
being added, double bond turns into a double bond, and things are added on either side of the double bond. Again, same thing, OH from the alcohol OR dash will get added, R and R will remain the same. And the second mole, again, same thing, R dash OH. Here also it should be R dash. Presence of H plus. So यहाँ पे this is a substitution reaction. So there's like one water molecule being lost, and you end up getting RC, OR dash, OR dash, and then R. So if this is a hemiacetal and this is an acetal, what do you think the name would be when the reaction takes place with a ketone? Aldehyde के साथ acetals आ रहे हैं हमें. Ketones के साथ we get a ketal. The first one, this would be a hemiketal, like half a ketal, only one alkoxy group attached, and this is called a ketal. So the reason why this needs to be done in acidic medium, like why do we need HCl or H plus present in general, is because the H plus from HCl protonates the oxygen in alcohol, and this makes it a stronger nucleophile. So basically, like what it's trying to say is the presence of H plus. So when R dash OH attacks it, it kind of turns it into R dash O minus, which is a really strong base. It's a really strong nucleophile. Okay. So guys,
This one,
let me know once you're done with this, then we'll do an example.
Why is it called hemiacetal and hemiketal?
Hemi is
I
basically
don't
half,
understand.
right? So acetals or ketals may you have two alkoxy groups attached to the same carbon. यहाँ पे you have only a single alkoxy group and the other one is still a hydroxy group. That's why it's hemiacetal, hemiketal. This is a full ketal, full acetal. Like,
Are these like different functional groups?
see, functional group, it's ether. Alkoxy is the functional group. Hydroalcohol is the functional group. When they are arranged in this particular way, so this class of compounds is called hemiacetal, hemiketal, or acetals and ketals. The way we said, if there's a alcohol group and a nitrile group attached to the same carbon, we call them cyanohydrates, right? So that way this type or class of compounds are acetals and ketals. Like amino acids are a specific class of compounds that contain amine group and carboxylic acid. So that's not a functional group. Like there are two functional groups present in that same molecule, but because of how they're arranged and which particular functional groups are there, it's a special class of compounds. That way, this is like a class of compounds.
Okay, thank you.
Yeah.
Ma'am, could you explain the mechanism once, like of the how the OH wala thing, ROH wala thing? I don't understand.
So ROH ka lone pair of electrons is the one, like, see, this has delta positive, slightly electropositive.
Yeah.
Oxygen is rich in electrons, got two lone pairs of electrons. Oxygen attacks this electropositive, like relatively electropositive carbon.
Yeah.
That's keeping in line with how nucleophilic additions take place. This is the one attacks. So
So
when
that's the oxygen, right? It will lose both the R and the H.
no, keep track. See, oxygen is forming a bond with carbon. So as
Yeah.
this bond is formed, double bond may say one bond breaks, oxygen takes this pair of electrons, and
Yeah.
carbon is satisfied by this lone pair of electrons.
Yeah.
So when this happens, because carbon is taking these lone pair of electrons, oxygen lets go of this hydrogen as H plus.
Oh, okay.
Yeah, so that's what is the end product. We have the same R, same carbon, same hydrogen. This double bond has now become a single bond. O minus hona chahiye tha, but either like from the medium, because this is losing H plus, like HCl gas is also there. Like it's the negative
Amen with OH.
attracts H plus, becomes OH.
Mm.
And by the nucleophilic attack, you have carbon attached to oxygen, and oxygen already comes with this R dash, so that's why this is OR dash.
So initially, when oxygen bonded with the carbon, it was both attached to still the R and the H, na? So it was like ROH, all three of them, like obviously oxygen, but then it was still connected to the R and the H, right?
Yeah.
Yeah.
So it was kind of like this H air. So oxygen, because it's like I'm already forming this bond with carbon, pulls these electrons, lets go of H as H plus. Similar thing happens, except it's more of a like this is an alcohol specific reaction where there's a water molecule lost. So oxygen attacks, like yahan pe takes the H, OH, and then this becomes another ether group, alkoxy group. Okay. Guys, make it quick, huh? At this rate, we're going to take more time to finish the chapter. Hmm.
H plus from HCl protonates the O and alcohol means like.
The reason why you have HCl also in the medium is to make this a stronger nucleophile. So basically, it like H plus attacks first, this becomes OH, like this makes it a stronger nucleophile in this particular process. Basically, the presence of HCl is just that.
But O is anyway electronegative, so why we need HCl?
It's anyway electronegative, make it a stronger nucleophile, you speed up the reaction. Makes it faster.
Yeah, done.
Okay. If I take a ketone, sorry, and treat it with a glycol, let's say ethylene glycol, for example, in the presence of HCl gas, what will be my final product? What sort of a structure can I expect here?
Will both the O's go or only one?
Both. So that's what we've seen, right? So this takes place in 2 steps. You want 2 alcoholic groups in order to get your final ketone.
So instead of 2 steps, now in 1 step only we'll get ketone.
Yeah, both the things are going to happen. But what is the final thing going to look like?
CRR and then OH.
Huh?
OCH2 OCH.
Yes. So you end up getting sort of a cyclic structure.
Can you go back one? No. Oh, acha, OR dash, yeah.
So because both of these, because it's a glycol, like since both the OH groups are there, you end up getting this sort of a cyclic structure as H2O. So this particular structure is called ethylene glycol ketone. Okay. So that's reaction with alcohols. Next. Ammonia and its derivatives. Which are the derivatives of ammonia? Like, what are we talking about?
What?
Sorry?
What did you ask?
When we say ammonia and its derivatives, what would be the derivatives of ammonia? What sort of compounds do you think would come under this?
Like
Amide.
Amide, yeah, amide is one. I wouldn't go to amide, but think amines and other things. So basically, ammonia is NH3.
means nitrite. What is that N3 one? That one.
No, that we are not going to. It's not an amine ammonia ka derivative. So you need to have NH or N with single bond explicitly. You can't have double bond, triple bond. That would be
So CONH2, is that a
CONH2,
derivative?
yes.
Carbamide.
Yeah. So basically anything like let's call it X, or X is halogen, right? Let's give it A, where A can be an alkyl group, aryl group, another NH2. In that case, you get something called hydrazine, like etc. That sort of a thing. Okay. So any class of compounds of this form, if A is hydrogen, you end up getting ammonia. But if A is not hydrogen, if it is something else, you end up getting this sort of this class of compounds. So aldehydes or ketones, when they react with A and H2, so NH2 may say, again, just like with alcohols, the nitrogen is going to lose one of the hydrogens, and you end up getting this sort of a compound. NHA and OH. And this particular compound is, again, this is converted to so this loses a molecule of water in order to give this sort of a compound. Let's do it with an example. For example, if we take ammonia, C double bond O plus NH3. So the intermediate's gonna look like this. So NH3 may say one hydrogen bonded to oxygen, this becomes OH, and the rest of it remains the same, gets bonded at nitrogen, so this becomes NH2. And this undergoes elimination, loses one molecule of water, OH plus the one single hydrogen here. So what you end up getting is C double bond N, and whatever remaining hydrogen, whatever part that remains as it is. So in this case, remain NH. Do you guys remember what this type of compound is called when you have double bond and then nitrogen NH?
Secondary amine.
No, secondary amine is when you have two carbons attached to the same line.
Cyanide. No, that is triple.
Mhm. We came across it in this chapter. It was an intermediate.
Carbamine.
No,
Imine.
imine.
Imine. Yeah.
Oh.
So if all of them are single bonds like R and H2, this is an amine or amine. And if you have a double bond, R becomes E, so imine. Like alkanes, alkenes, amines, imines. That way. There's a whole table that's given in all-in-one. So once you've written down like a general form of the reaction, I'll just display this. So note down this whole part.
I was writing like the previous.
Okay. ठीक है. This. Yeah, you don't have to note down an example because this is one of the things in the table. So just note down whatever is in black, like the general form, and then note down that table or flowchart sort of a thing. It's easier. You'll have all of the different variations then.
Why is it ethylene glycol ketal in the previous one?
What?
Why ethylene glycol ketal? Like
What's the name of this compound?
No, like you said, jo bhi, whatever we start with and then we add. Oh, that was a different thing.
That was cyanohydrin talked about. Yeah.
This one is just like you have to remember the name. So that's it.
In case it's asked.
What is that example ANH2 ke baad?
This is one case. Like if A was hydrogen, then this becomes ammonia, NH3.
No, after A in the next to derivatives.
Oh, where A can be an alkyl group, can be an aryl group, it can be another NH2 group. Like there's lots of cases. So I'll show you the flow chart, right? So that covers all of the different cases. All the different,
Miss, what is that RNH2 that you've written? Like, is it in relation or you're just showing that amine ka formula is that?
oh yeah, no, amine ka formula. It's not part of the reaction. Yeah, like note down till here, whatever's there in black. Uske baad note down the flow chart. So all the different derivatives of ammonia are like presented there. It's easy. So they all follow the same pattern. So it's just practice of like writing different things. All the cases, same thing happens. Hydrogen, this becomes OH. This the remaining part, nitrogen gets attached over here. And then there is one water molecule lost. So the OH here and the H here is lost as water, and then this becomes a double bond. So you just get different names of the compounds depending on what is attached here. So if you have NH, then you get an amine. If you have something else, amides, then you have something else. Okay. Smira, done noting till here?
Yes, ma'am.
Okay. Yeah. Visible, right? Or like, should I make it bigger?
Oh, no, it's visible.
Yeah, this table. Yeah. Yeah. So, C double bond O. So if you add hydrazine, which is N2H4, this is rocket fuel. You end up getting something called hydrazone, which is double bond N NH2. You add phenylhydrazine, where one of the hydrogens substituted with a phenyl group, you get phenylhydrazone. Ammonia ke saath amines. Amines ke saath you get a substituted amine. So instead of hydrogen, you have an alkyl group. Hydroxylamine, NH2OH, you get something called oxime. This is called carbazide. So semi-carbazide, and then this whole compound. So yeah, just different cases. All of them follow the exact same format. So you just need to know the names of the compounds you end up getting.
What is the difference between hydrazone and hydrazine?
Hydrazine is NH2NH2. Hydrazone is when you have a double bonded carbon attached.
Right now, this is like this because it's just a generalized form. When they give a particular compound, we'll have CH3, CH2, and then we'll have to identify and write. Right?
Yeah. But like everything else stays the same. So whatever is attached, whether it's an aldehyde or a ketone, so that
Yeah,
part.
but if we're doing it now under aldehydes ketone, so we know where it is from. Like if you give this just like that, when there's like so many other organic chapters, how are we going to differentiate?
Because you look at the reactant and then you have an aldehyde or a ketone, and you'll be able to predict the compound. Suppose you're given the other way around. Like suppose you given one of those questions where something किसी का like an organic compound of the formula C4H8O, something like that. So in this case also, based on the number of hydrogens, you'll be able to figure out whether it's an alcohol or an ether, or whether it's like an aldehyde ketone. And once you have that down, you figure out, okay, what else is it reacting with. I don't think we've come across reactions with amines ka derivatives in other classes of compounds. So okay, so if it's like a reaction with hydrazine, reaction with amine, reaction with ammonia, then you'll have an idea ki, okay, so this is the final product we're forming. Another way to look at it is, suppose you given the product, sub mein you just have C double bond N. So the thing is, you get C double bond N only from the reaction of aldehyde or a ketone. So basically, you're substituting the oxygen with the amine derivative. So that's another way of recognizing. Okay, if my final product, if my final structure has like a C double bond N, then okay, maybe I started off with an aldehyde or a ketones. And then you look at the rest of the structure, what is N bonded to, what is carbon bonded to figure out, okay, what your original reactants are. Okay, so note down this information first. And then when you look at the questions, like obviously your first round of questions are going to be trying to figure it out based on this. So that way you'll get familiar with, okay, what sort of questions will we get? How do I figure it out? Okay, so that's why right from the beginning, I've been telling you guys, rather than taking it chapter by chapter, as we do these chapters, just make a list of all the reactants. So if this is my reactant with this reagent, this is the product I'm going to get. So I think take it that way. That way, it won't matter where you study or how you study, wherever you find the question, you identify, acha, ye product hai, ye reagent hai, matlab this should be my original reactant, or this is my reactant and reagent, I should get this product. Treat it, take it that way. Okay, there's 5 minutes left. Note this down. I think this will end by the time you guys finish. Be right back. Right, guys, how's it going? Out of 1, 2, 3, 4, 5, 6, 7, how many have you done?
3.
Okay. And it's not necessary for you to note it down exactly as it is. If it is easier for you to write each reaction one at a time, you can do that. If it's easier for you to write it in tabular form, you can do that. Make it easier for you to study and refer.